this video, we are going to explore how to apply the Simplex method to an application problem. So this problem was taken from the homework set in myopenmath.com. For our class, it's number 2 from assignment 23, so homework 23, number 2. And I just kind of wanted to walk you through what we're going to do here and what you're looking for. So if we first read the problem, we have Discount Printers manufactures 2 types of inkjet printers, a consumer version and a business version. The company can make a total of 119 printers per day, and it has 259 labor hours per day available. It takes 1 labor hour to make a consumer inkjet printer and 3 labor hours to make a business inkjet printer. Profits are $40 per consumer inkjet printer and $55 per business inkjet printer. Okay, so a lot of information there. We're asked to maximize P, and if you look at the bottom, it says the maximum profit is. So it makes sense that we're trying to maximize the profit for a business. So that's what we're looking to maximize. So that's going to be our maximize function. The other thing is, in real life, we know that we have constraints. And so this problem, we have the constraints that they can only make 119 printers per day. So that's the most they can make per day. And they also have the constraint of labor hours. So they can only have 259 labor hours per day. So they have to stay within those constraints. We can see that below we have 119 is shown as a constraint, and 259 is shown as a constraint. So that makes sense in this context. So let's see what we can do to maximize profit. They talk about profit, so let's use green here. They get $40 per inkjet and 50 are consumer and 55 per business. So it tells us in the parentheses here, use X for consumer and Y for business. So if they get $40 per consumer, that's 40X. And they get $55 per business printer, that's 55Y. And so if you add the profits for each of the types of printers, then you can find the total profit they can make off of both printers. And so that's going to be the equation for the amount of profit they can make for the 2 types of printers. And so we want to maximize that. Now the constraints that we have are based on the number of printers they can make and the number of labor hours they have. So the number of printers they can make a certain number of the consumer printer, so that would be X, and then they can make a certain number of the business printer, so that would be Y. So if you add up the number of each type of printer that they make, it'll be less than or equal to 119, which again is the most they can make per day. And then the labor hours is similar. So for the labor hours, let's see, they give us some information. It takes 1 labor hour per consumer inkjet printer and 3 labor hours for a business inkjet printer. And so for X, it's 1 consumer hour, and for Y, it's labor hour. It's 1 labor hour for the consumer printer, and it's 3 labor hours to make a business printer. And so if we add up the number of hours that they take to make each type of printer, that cannot exceed the 259 hours maximum per day. So that's how we write our equation that we want to maximize, as well as the constraints, the inequalities that we're constrained by. And so now what you would do is you would use the Simplex method and this information to solve. And so all they're asking you to input now is the number of consumer inkjet printers that you would use to maximize the profit, the number of consumer business printers. Oh, that doesn't make sense. I'm sure it should just be business, not consumer. So business printers to maximize profits and the maximum profit. So here You're looking for the maximum profit, and this is the x, and this is the y variable. So given that we want to maximize the profit under the constraints given by the inequalities, we're going to write the tableau, the simplex tableau, and then we're going to solve using the simplex method. So the tableau, we have, remember our columns, x, y, slack variable for the first inequality, the slack variable for the second inequality, our p, which is our other variable, the profit, and then we have our constant. Okay, so that's going to be what we put in here. And then we have the first equation, the second equation, and the profit equation. And so the first equation is going to come from this inequality. We're going to have x plus y plus the slack variable is 119. The second equation is going to come from this second inequality. So x plus 3y plus the second slack variable is equal to 259. And so we'll be able to fill in our matrix here, 1, 1, 1, 0, 0, 119, and then 1, 3, 0, 1, 0, 259, and then the last equation, the profit function, remember that we want it to be set equal to 0 because we want the constant to be on the right. And so we're going to have negative 40x minus 55y plus p is equal to 0. And so we leave the p where it is, we leave the p positive, and we move everything to that side. So that's going to give us negative 40, negative 55, 0, 0, 1, 0. Okay, so now if you don't remember how to go through the simplex method, please go see the video on that. I'm just going to kind of go through it, assuming that you can follow along. And really the point of this video was to set it up. But let's go through and just get the answers and see how we would plug them in. So the first step is finding the smallest number, or the most negative number, in the bottom row. So that would be the negative 55. And then we would need to find our pivot. And we do that by dividing the constant by the number in that column. So 119 divided by 1 is 119. And 259 divided by 3, it doesn't go in evenly. It's approximately like 86 point something, 86.3. You can see that the 86.3 is smaller, so that will be our pivot. So 3 is going to be our pivot. So what we want to do there is we want to now zero everything above and below that 3, that pivot. So the 1 above it needs to be a 0, and the negative 55 below it needs to be a 0. So to zero out the 1, you would multiply negative 1/3 times row 2, and you would add that to row 1, and you would replace row 1. And that should give you a 0 in the position where the 1 is. And then you want to zero out the negative 55. So to do that, you would multiply row 2 by 55 over 3, add that to row 3, and replace row 3. So once you do that, you are going to get for row 1, 2/3, 0, 1, negative 1/3, 0, and 98/3. Row 2 remains the same. And then when you multiply row 2 by 55/3 and add that to row 3 and replace row 3, you will get negative 65/3, 0, 0, 55 thirds, 1, and then 14,245 over 3. All right, so now you've done that. The next thing to look at is the bottom row. If you have a negative number still down there, you need to make that your new pivot column. And so we still have negative 65 over 3. So that's now going to be the pivot column. To find the pivot, we're going to do the test ratios. So we'll do 98 over 3 divided by 2/3. And we'll do 259 divided by 1. So we will get 49 and 259. 49 is smaller, so that means that 2/3 is now our pivot. So that's now our pivot. So we want to zero out everything below that. So in order to zero out the 1, we're going to multiply row 1 by negative 3/2, add it to row 2, and replace row 2. And that will give us our new row 2. And then to get the 0 for the negative 65 thirds, we're going to multiply row 1 by 65/2, add that to row 3, and replace row 3. So when we do that, we're not changing row 1, so I'm just going to rewrite that. Okay, and then row 2. So negative 3/2 times 2/3 is negative 1 plus 1 is 0. And then for the next one, we'll have 0 plus 3 is 3. And then we'll have negative 3/2 times 1 is negative 3/2 plus 0, negative 3/2. Negative 3/2 times negative 1/3 will be positive 1/2 plus 1 is 3/2. 0 plus 0 is 0. We have 98 thirds times negative 3/2. That's going to be negative 49 plus the 259. So that should give us 210. All right, and then we're going to do something similar for row 3. So we're going to multiply by 65 over 2 to row 1, and then add that to row 3. So when we multiply 2/3 times 65 over 2, we will get 65 over 3, and add that to negative 65 over 3, we get 0. Now we're going to do 65 over 2 times 0, which is 0, plus 0 is still 0. All right, 65 over 2 times 1 is 65 over 2, plus 0, 65 over 2. 65 over 2 times negative 1/3, and then add that to 55 thirds, you're going to get 15 over 2. 65/2 times 0 is 0, plus 1 is 1. And then 65/2 times 98 over 3, plus 14,245 over 3, you're going to get 5,810. All right, we have no negative numbers in the bottom row, so that means we're done. And so now what we want to do is write the associated equations with each one. Remember what each column stood for. So this was X, Y, S1, S2, and P. So as a reminder, we don't care about the slack variables. So we're going to ignore those when we're writing our equations. And so our first equation is going to be 2/3 X plus 0Y plus 0P is equal to 98 over 3. And so we can solve this by multiplying by the reciprocal, 3/2. And so we'll see that X is equal to 49. Okay. Similarly, we can do the next equation. So from the second row, we will get 0x plus 3y is equal to 210. So divide by 3 and we'll see that y is equal to 70. And then from the last row, you will see that you have 1p is equal to 5,810. And so what this is telling you in context of your problem is X was, I believe, personal. Let's see. X was consumer printers. So you would make 49 consumer printers and 70 business printers to maximize your profit. And your maximized profit would be $5,810. And switch over